All right, everybody, come on in, grab a virtual seat. Glad to have you here. Welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. And this edition of Meetup, our 286th, being recorded on Thursday, April 15th, 2021 at 6 p.m. U.S. Eastern Time. We've got Luis Majano speaking on To the Future with cbFutures. And before we get started, I just want to share a couple of announcements. So we do record all the sessions. This one is being recorded as we speak, and when we're done, it'll be available to anybody to see. And it's on YouTube, but you can find all our past sessions more easily at recordings.coldfusionmeetup.com. And there's a YouTube playlist there for all the meetings since 2015 have been on YouTube. So check that out. And then I always want to remind folks that if you're at all interested in presenting, we welcome any presentations on anything tangentially related to ColdFusion or directly. And just reach out to me, and you can learn more, about how to reach me and how the meetup works and stuff like that at speak.coldfusionmeetup.com. And with that, I'm ready to turn it over to Luis. So, Luis, thank you very much for coming on, and look forward to you presenting. Take it away.
All right, thank you, Charlie. Appreciate it. So thank you for having me for this presentation today. So I'm glad we're recording this, and unfortunately we cannot be together, so we're still virtual. But I promise it'll be an action-packed little session. No slides, so that's gonna be an interesting one. Okay, so we have no slides. We're gonna be purely seeing code, executing code, tons of code, right? So this session is called To the Future. I gave it for the very first time at Into the Box last year, and we have been upgrading it as time progresses. And we're going to be introducing to you guys the power of asynchronous and parallel programming, yes, in ColdFusion. So we're going to explore this asynchronous world, okay, in ColdFusion. Okay, and Java has supported really just a tremendous amount of robust and functional approaches to synchronous programming since JDK 8. And we brought and ported over most of the API for asynchronous and parallel programming into ColdFusion. Okay, so if you want to reach me, here's my contact information. Here's the link in GitHub of all the source code that we're going to be programming in today. And pretty much anything that we do is going to be here. And if you need to contact me, there is the information.
Sorry, I'm having trouble hearing you.
Oops. All right, so let's start off with our agenda. So to start off, let's talk a little bit about the non-blocking movement, which has really shined especially in Node.js. This is what really made Node very, very prominent, is with its event loop, is the ability to actually do non-blocking programming, and the majority of languages actually support it today as well. So it is really, really nice to see this. It is a really a movement to more asynchronous and parallel computations. We're no longer blocking, and in the traditional, server request response model, we actually have the ability to do things in an asynchronous manner. Now, one caveat: asynchronous and parallel computations can actually hurt your brain heavily. So very, very important. There is no more dump aborts. Okay, you are in a non-UI mode. This is something that really gets a lot of programmers in any language, is the ability that you are now detached. Okay, you're working in an ether space, and it's not easy. Okay, you have to worry about so many things. Okay, you have to worry about concurrency. You have to worry about shared resources, right? You have to worry about, okay, what happens when there's exceptions? So there's a lot of concerns that we don't get when you're in a traditional synchronous approach, but obviously there is a lot of benefits. Okay, so we see this overall movement to computational programming. Okay, very, very important. And now JavaScript made this very, very famous with callbacks, right? And in callbacks, you kind of refer to them as sometimes callback hell, if you've ever been in that approach, where you're basically making callbacks of the callbacks of the callbacks of the callbacks, and really can make developers cry, right? It's really not nice, but it got us there somewhere, right? It was that never-ending nesting collection of futures, right, of closures and functions, and it's really not very nice, right? So that was kind of the beginnings of this move toward computational in a synchronous fashion, right? And then they basically created in the JavaScript world the concept of promises. Okay, this really made JavaScript very, very popular, right? It gave you some sanity back into development from the callback hellfire that you had been submitted to. And the concept was that you would have 3 different states on this promise, right? You have a resolve, a reject, and a pending. Okay, a resolve is when the actual promise has been completed. A reject is if it's an error or something else. You threw an exception, and a pending state, which is that the actual promise has not been executed yet. So these are very important premises for us to start with asynchronous programming, right? You can also cancel and resolve them programmatically, right? And the concept of a promise becomes that you actually get what are called 2 channels of communication, okay? A data channel and an error channel. So if we actually open our first example here, let's look at a promise track. So a promise basically works on the concept of 2 channels, a data channel and an error channel, okay? And every time that you have a computation, okay, or something that executes, you can move from one channel to the other, okay? So you can be zigzagging and you can execute another function which renders a result, which can then be sent to another function in the promise and sent to the result, etc. And then move to the error track. Let's say there's an exception, which then goes into another function, which you can try to recover from that exception. And let's say at one point you actually recover from the exception, you can move back into the data track, right? And basically get a final result when you want to resolve that promise. Okay, so promises have this premise of these 2 channels, and they can be zigzagging back and forth, right? Now, obviously, we've been talking a lot about JavaScript, but it is important because this is where all this functionality kind of came from, and then we can start moving forward. Okay, so remember, 2 tracks of communications is what made promises really, really interesting. Okay, we're no longer nesting things, but we're actually acting on the concept of that something will be available to us. Okay, now with that said, what about ColdFusion? Well, in reality, ColdFusion has basically 2 approaches at this point, okay, natively in the CFML engines. You have a CF thread, okay, right? But CF thread is really great for very basic threading. That's it, okay? It is easy, but it has tons of issues, okay? And they can also make you cry, okay? There is no way to choose where your thread runs. Okay, you're at the mercy of the CFML engine vendor. There is no concept of returning data or actually retrieving that data at one point in time. It's really up to you to monitor and track this data. Okay, they give you a thread scope, and then you have to actually maintain how to use that thread scope. Okay, it's hard to manage these threads. Okay, you actually have to use them by name, and then how do you cancel? How do you monitor? How do you pause? You really don't have these capabilities. There is no functional approaches to this. It's very, very simplistic, okay? And managing multiple threads and joining can really be cumbersome and really can be a horrible experience, okay? So CF thread has its place, okay? It's very, very basic when you just want to basically issue a thread and you're done, okay? However, then until ACF 2018 and Lucy 5.3, we got into the concept of run async, okay? This is a step up. Okay, we no longer are in a tag approach or a context approach as the thread. We can actually run an asynchronous computation and get basically a result back, which is a future. Okay, there is not a concept of a promise. It's basically a future. And if you see the actual class return from both Lucy and Adobe, it is a Java util concurrent future. Okay, it also is a very simplistic object that handles what a future result of that computation will happen. Okay, there is a very simplistic error handler. Okay, there is no way to recover or continue executing pipelines after an exception. Okay, so the concept of the 2 tracks is really broken. Okay, the future just gives you one result or one exception. There is a to actually choose where these threads run. Okay, at the mercy of the CFML engine vendor to decide that for you. Actually, in Lucy, it actually creates a single thread executor for every operation, which is actually time consuming and actually consuming resources in order to just execute your events. Okay, so there is no way to actually operate on multiple computations at once. No way to combine computations, no way to compose computations. It only works with closures. You actually want to call components and methods. You actually have to proxy the calls in a closure into a method. So it's still very cumbersome. It's an approach to threading, but the reality is that it's very, very simplistic. Again, okay, in this case, run async will just execute a computation for you, and then you can wait for it and then do something else with it. It is important to know the history of what we can do at the CFML engine level before we move forward. Okay, so that's basically what we are talking now, which we're now a little bit further. So now that we've discussed these concepts, well, what about Java? Well, Java introduced in JDK 8 the concept of completable future and completion stages. Okay, executors, lambdas, and much more. Really functional approaches for programming. Okay, now completable futures is basically a fancy name that Java developers call promises. So the reality is that completable futures are promises, but at the end of the day, Java developers like to complicate things sometimes, and even names. And in this case, they call them completable futures instead of calling them futures or promises. So there you go. That's where the name futures, completable futures, comes from. And this is a very extensive, very well-documented API, all in the JDK. Okay, and we have ported the majority of the functionality into what we lovingly call ColdBox features. Okay, so you can use this on any CFML engine, starting with the usage of JDK 8 and above. Okay, the best is that I would recommend is to use JDK 11, as it has a lot more features. All right, so let's begin exploring the concept of futures for ColdFusion through ColdBox Futures. All right, so a ColdBox future is very similar to the JavaScript Promises API that we have been discussing, okay, but is now backed by this completable future API. We've adapted it to our dynamic language, so it will do all the casting for you. It will do all the enhancements for our dynamic language. Okay? We have one class called the Async Manager. This is the class that is in charge of all the asynchronous computations and capabilities. Important, it can be a standalone. Okay, this can be used on any ColdFusion application, okay, or you can use it in ColdBox. So we have actually created this in a way where if you just have a ColdFusion application and you want to use asynchronous computations or schedule tasks, you can use the standalone version via basically Wirebox. Okay. However, if you are in ColdBox, you do get a lot of more features. Okay, and we're going to discuss some of them. But in reality, our functions is that through this Async Manager, we're going to be able to create our futures. Our computations, we're going to be able to create executors as well, which is collections of thread pools of how we actually want these workers to execute, and schedule tasks. Yes, we have tons and tons of work for scheduled tasks as well in the asynchronous computations. All right, so let's start to see a little bit of code on what we can do with futures. So let's start with creating cbFutures. So let me open here the cbFutures stages, and here is where you can see what happens on completable futures. When you call a completable future, you have the same two-track concept of promises, okay? A data track and an error track. You're going to have some type of functionality that's going to execute a function. It's going to then proceed to pass in the result to another function, which can then pass to another function, et cetera, et cetera. If there's an exception, it'll move down the track into the error track and then zigzag its way until you finally decide when that should end, okay? So we're going to be working a lot with closures, but you can also work with CFC instance methods, okay? And we're going to be working also with native CFML constructs, okay? But the idea is that in cbFutures, you also have the concept of the stages, which is very, very important. All right, so Dwight Walker is saying that the font is too small. All right, let's go one more step. How about now? I'm thinking it'll be better. We'll try it now. We'll see how it's if it's a little bit better this time. All right, so the concept of the stage is very, very important. Okay, so we now have the stages that we need completable futures. All right, so let's work and start creating now a future. Right, so let's move into creating a future. So we're going to go through some code, and we're actually going to be executing some code. I see you have a runnable here, a run it. So I'm going to discard it, and I'm going to create a new task right here. Okay. And here's the task. Okay. Go one step further. That's going to be incredibly huge. right? Let's see if that's better. So here is a task I've created. It's basically empty. And here's command box here on the right. Okay? I might move it to the left because the space here is kind of poor. But you can see here that there's command box, and I have a script that basically monitors my monitors my file, and anytime I run it or save it, then it'll run it, right? So this way we can start working with it. We can start seeing what we need to do. So let's create now some futures and working with it, right? So I'm gonna basically copy our code that we have here, and let's go through it. All right, we have an asynchronous manager that we've created. It's just basically creating the asynchronous manager, okay? And then we're gonna have a run function, which is our task, and we say we're gonna start from, and then we actually spit out the name of the thread. We actually have here a little helper to give us the name of the thread that we're on. And we're gonna tell to the asynchronous manager, hey, I want a new future, okay? And we're gonna pass in a closure to this future, and we're gonna say, hey, do a computation, okay? So this computation is gonna execute at one point in time. We then have a then operation, which receives the data, okay? And then we actually print the data back into the screen. And of course, we have a lot of comments here because we're going to be doing a little bit of exercise here, okay? We have another function here called compute that all it does is print a green line that says computing from and the thread name and returns the value 2, okay? So when I actually come in here and actually save this, you're going to see on the right that it actually starts from CF thread 15. That's the actual thread that it used to actually execute the run task. And then it says computing from the fork join pool, okay? And it gives me a value of 2, which I never saw at one point, right? So I'm going to actually go to the console here to make sure that these things are actually executed, right? And now in command box now, immediately it will render to the screen. And now you can see the number 2 being rendered to the screen. So what happened? Well, right now, I said, I want to get a future computation. It's going to execute, and you see that it actually executed on a fork join pool. And if you've never heard of this, a fork join pool is basically a common thread pool that every ColdFusion engine has, well, actually any Java application has, and it's pre-configured for you, and it ran there, okay? Many things can run in the fork join pool, okay? We just said basically go execute in that asynchronous executor, and boom, you're done, all right? So great. Okay, I got it. So what about the results? Okay, so let's go in here and start commenting things out. So let's start actually getting the results. So here I have the blue line that says the future and then the value of the result. So if I actually save this, you'll see that there is no value. Okay, so I forgot to return the data. So remember, important that every time that you do an operation on a future computation that you need to return it, right? So once I return it, then you see that it's actually coming back in here into my future, and it's giving me my result of 2, which I also outputted right here in the green line right here, okay? So very simple one. I've created my future, it executes, and I've been showing you different things. All right, so what about which thread does the then actually execute on? Okay, so that's very important. And actually, like I said, in Lucy and Adobe, they actually have their own executors for those. But in us, we haven't. We actually let the JVM decide. And in this case, the Java JDK decides that it will jump on the actual fork join pool because it's still active. So it attaches itself to that thread as well. But the important thing about this is that it's going to be non-blocking. Okay, so that means that the JDK will decide what is the best approach to not block. That's the whole point of these futures. Okay, so if we actually come in here and we add a little sleep operation into the compute and it starts running, right, then the JDK can change its mind. In this case, it didn't change its mind. But in other cases, it could change its mind and it can actually execute it in the main thread as well. Okay, the point is here is that it will non-block as long as it decides it cannot block. Okay, all right, so this was my get operation. I can also use the get operation with a timeout. Okay, so this is also an enhancement. I can actually say, I'm just going to wait for 1 second and then give me the result. So if I actually save this and I try to get it, it's going to blow up because obviously there is no result, okay, yet, prepared for me yet, because the get operation is supposed to block, okay? The get operation says, hey, give me the result at this point in time and only wait for 1 second, okay? In this case, 1,000 milliseconds. But since there was no result, it just blew up and it continued operating. operation. And you see at the end, when the computation finalized, you can actually see that the then was executed in another thread. Okay, so heads are starting to hurt already. All right, so let's move on and actually do now another get operation with a timeout, but actually having a default value. So in this case, I'm going to have a default value of 5 because I am desperate. I need that computation to execute. But if the computation does not execute, then just give me the value 5. Okay. So the value was 5, and you can see here at the end, the future was 5. That was the result of the computation. Okay, so very, very interesting. Okay, if you get desperate and you need to actually get a result or a default value, okay, let's say name resolutions. Okay, you want to actually do a name resolution, but you don't want to wait for a specific amount of time. You can actually put a timeout. But very, very interesting is that the actual worker continues to execute. Okay, so it doesn't mean that your computation is going to be canceled. No, your computation will continue, and your entire pipeline will continue to execute in the background, okay? But you are actually retrieving the result at that immediate point in time, okay? Now, you can also be extremely desperate and say, get now, okay? And get now will basically not wait, and it'll just give you that. And if there is a result, it'll give it to you. And if there is no result, it'll give you the default value, okay? So this is the most desperate of the desperate attempts to get your computations from an asynchronous computation. You don't wait. You're like now, and whatever it is on the pipe, it'll give it to you. So if we don't have any sleeps, we might get lucky. We might execute immediately and give me the result. Ooh, I mean, we did, see? So it actually gave me my 2 at that point without any of those sleeps, okay? So very, very, very important, right? So let's do a little bit of more features here. Let's get rid of the get here, and let's just remain with the first one, okay? And you will see also that there are many of these then operations that we're going to start discovering. Okay, so let me cancel all this and go back to my new task, and then we'll start with a different example. Right. So basically, creating a future is really easy. You basically use a new future and you start composing these types of pipelines. Okay. Now let's look at another example here to try to see the non-blocking mode approach that I was talking about. To try to see if we could map it into a different thread group. So you can see it's very similar. We have the creation of a future now. Okay, so instead of having it in line, we just create another method called create. Okay, we call the async manager. We say, give me a new future of the computation. The computation is here, computing from the different thread. And then once I create, I say then run. Okay, so this is different than then. Okay, so and we'll discover what it means. And here we also are having a little print red line, and we're going to just use our consoles because we want to make sure that they actually go to the console. Okay. And we can do it then run, and then we sleep for 2 seconds at the end of the task. So if we actually run this, you'll see here that it started the thread from CF thread 15. It actually executed the computation in the fork join pool, but the then run actually executed on the main thread. Okay, so this is the same thread that started it. Okay, now this is interesting, and it happened because there was no blocking mode. It actually happened so fast that the Java completable future said, I want to execute a run operation, okay, on the data. Now the difference between then and then run is that then run does not return the data. If this was a then operation, I must return the data because I want to complete the pipeline. Okay. But since I just don't care about the result, I just want to run something. So I just say, hey, I want you to run something with the data and then don't return anything back. Okay. So once I do that, you can still see that it runs on the same main thread. Okay. So let's do something. Let's try to do a block operation on the actual computation and make it a little bit slower. And look what happens. It actually created that thread on the same fork join pool because we have a delay. So it didn't want to block the main thread of execution because the main thread is now blocking here. So it actually was smart enough to switch the workers for you and then be able to non-block the execution for you. So this is something that I wanted to show you the inner workings of how the Java SDK works. As ColdFusion developers, we don't really have to worry about these things. But if you do, right, it's important to know the fact that you will never block. And that's the important thing. It will never block. It will always execute on a different asynchronous computation. Okay. All right, let's close that. All right, so let's charge ahead. All right, we talked about this thread of execution, right? But we can actually change the thread pool. And this is something very, very important, that we don't have any of these capabilities on any of the engines. Okay, so let me go back to the custom pool example, put it here. So this, now we're going to be creating an example where me, the developer, I want control of the executor. Okay, the executor is basically a thread pool or a collection of threads that I can assign by name. Okay, and the ColdBox Async Manager will track it for me. Okay, it will register it, and I can actually tell it how many threads I want on this specific group. Okay, so I've created my own group, and I call it IO bound. Okay, I know I have 8 cores in my machine. I want to take advantage of them, so I'm going to create a thread group that is called IO bound with that specific amount of threads. I still have my compute method. I still have my create method, but now instead of just having the actual future that it's going to execute, I actually pass in the name of the executor I want this to execute under. Okay. So now I've taken complete control of how those or any other tasks or computations will execute right here. So I can see starting from that thread, I create the future. Okay. Then I actually pass in this data right here. I'm executing it from somewhere, right? Let me also add my consoles here so we can see them. Okay, so we can see what we happened, and we're going to do then run, just because we're not returning anything, just to be consistent. It's not going to break. You'll see that we can do this as well. But once I do this, it'll run, and you can see here that it's now executing from a very different name. It's no longer the for join pool. It's now the pool. Okay, pool 7 or pool whatever it names. Okay, so this is the important part, is that now I've created my own management, okay, for this executor. Okay, now this is important because there will be a time or a place where I want to be able to cancel tasks, okay, or I want to monitor tasks. I want to say, okay, how many tasks are you running? Or maybe I'm connecting this to a RabbitMQ or WebSockets, and I want to be able to monitor those connections. What if I wanted to shut down all connections? Well, very easily I can, at the end, say shut down. And this will kill basically everything that's running inside of that thread pool. Okay, so very, very important. Now I have complete control as a developer of where my computations are going to be executing. Okay, I can register these in the Async Manager. They're going to be available for my entire application. And then I can decide when I want to shut them down, if I need to shut them down, or I can get metrics on them. Okay, so very, very important, having the capability to run this asynchronous computations wherever I want. All right, so let's go down deeper into the rabbit hole. Okay, let's look at the different pools that are available for you. So Java offers 4 types of executors in the JDK. A fixed executor, which is basically you control the amount of threads. This can be whether you want a CPU-intensive task or an IO-intensive task. You can create a single executor, which basically becomes a first-in, first-out pipe. Okay. Now remember, Lucy and Adobe both use this for every then operation. So every then in a run async will execute in its own single thread executor. Okay, you have no choice. Then we have a cached, and this is extremely interesting thread executor that we have gotten incredible performance from because it's an ever expanding demand queue. This means that you can throw whatever amount of threads you don't choose. Okay, it means that it will increase as many threads as you want, and it will control them for you. And it will try to reuse them as much as it can for you, and then destroy them when it needs to. Okay, it'll monitor them for you, and it will do an ever-expanding on-demand queue. Okay, so very, very important. This is great if you're going to be creating work queues where you don't care how many workers, or you can get a rush of traffic, and you can execute 100 computations at once, and it'll expand and contract as you go through it. Okay, and then the last one is scheduled tasks. So if you have had any type of issues doing scheduled tasks with ColdFusion, okay, where you need to decide, okay, where do I run my tasks? Do I use Jenkins? Do I use GitLab? Do I put them on cron? Do I put them on the Windows Task Manager? Do I put them inside of the CF? What if I have multiple servers? Well, those stories will be long gone with the scheduled task manager, okay? So this allows you to schedule your tasks in extreme detail fashion, and I'm not sure we're gonna have enough time to go through them, but I can point you to all the stuff that we've created for scheduling tasks. All right, so how do we change all of these different pools? So let's look at an example here. Bring them up to our runnable here. And we created the same IO bound, but instead of doing type fixed, we did a type cached. Okay, and this is where we can actually do different types. Okay, there's also very nice methods where I can say, give me a new cached executor, a new pool executor. So if we actually go into the Async Manager, you will see that there are many types of executors. Okay, new single executor, new cached executor. Okay, so you have little shortcuts. Okay, but here I just wanted to show you the type there, cached, so you can get that IO bound. Everything stays the same. I've just basically changed the executor. And then let me shut it down. Let me be a good programmer and shut it down. So I'm going to say IO bound shut down, right? Let's see, red line. Okay. And now I can execute that. It's running. You can see on the right-hand side. And then at the end, I killed the executor and we're done. Okay. So very, very easy. I can create any type of executor, and then I can be submitting tasks into that executor, okay, through these future exceptions. All right. All right. Let's go down further and further the rabbit hole. All right. So we went through the introduction of the ColdBox future, how to actually create these futures. When you're working with them, very easy. You just say new future, and then you start off that pipeline. So let's discover more about these magical pipelines that we've been talking about. So the Java API offers, of course, 3 approaches to then operations: a then apply, a then accept, and a then run. I'm not going to go through them because they're very Java specific, because obviously they are strongly typed. Okay. For us in the CF world, we're going to be worried only with then and then run. Okay. The basics is that the then operation can return a result. The then run does not. Okay, the then run is like it says, then run, and it never expects anything to come back. The then can expect something to come back, but it can be null as well. Okay, now one of the curiosities of completable futures that really is very, very interesting is that they never complete, they never end. So again, this is such a gripe with the Java developers of choosing the name of completable future, because they never complete. Okay, it's like the Sharknado movie, right? They always continue creating them. So let's look at some of these examples. So here's the then. Moving to the runnable here, and we're going to start going through it. So let's see what we create. All right. So in the run method, we're going to be starting, of course, from the thread. Okay. We have our async manager, and we left our IO bound. We just moved it to a cache one just for kicks. We're going to create a future. So you can see here the create method. We say to the async manager, hey, give me a new future. Here's my computation. Run it on the IO bound executor. Okay. Then, okay, I'm going to print where I'm getting that result, and I'm going to put the green line of the data right there. And then I do a more pipeline. I did a then run, which is hello from runnable land. I do a then operation, and then another then operation. Okay, and then I wait for more results, and I sleep. And then, of course, I am going to kill my Sharknado executor. So if I actually execute this, you're going to see on the right that it says there waiting for results, sleeps, and then it shuts down. Maybe I should have put a message here that it says, okay, I'm done, right? So let's do print line, red line, executor kill. Okay. So let's run it again. It's going to be waiting for the results, and then at one point it died, right? Now, the interesting thing is that none of these actually worked, right? You see that nothing executed. So then you start going back and saying, okay, remember, the then operation was expecting the data to be returned. And then the future pipelines, when they executed, they actually did not execute because the data was never presented, right? So we can actually need to be able to remember that this data needs to actually be returned, okay? So you can see here that now once the data is returned, then we can say, okay, hello from runnable land, because now we can run. Then we actually say all done. Here's the data, okay? And then we can say then again with the print green line and then again. But again, we also have to be returning the results, okay? We're here, we're just printing and printing and printing. I can say another then run, okay? Now it says all done. And then I can say then run it here and then not really. So as you can see, you can start mixing and matching. The then operations are expecting the data to be returned to continue down the pipeline. Then runs are just single shots of runnables, okay, that you can do. So, and I can basically take through this and create these pipelines. You can actually save these pipelines on a specific variable and then execute them later. Lots of flexibility here, okay? I can create right here my future, right? And I can say, here is my future, right? And I can create it and then do some type of other operations right here. And then another point in time, basically say, okay, continue the pipeline. And then I can continue my pipeline right here, right? So I can do other stuff right here, other stuff, go do another computation, right? Go get some more data, right? Do another sleep operation, right? But then at the end of the day, once I get into it, then it will still run once it reaches that point in time. So very, very important. It's very flexible, okay? Because you're actually receiving a future object that then you can attach the pipelines into them, okay? All right, so that is the first example of then operation, okay? But we have a little bit more feature sets that we can get here, more important ones, which is data transformations. So there might be a case where we're calculating, let's say, a tax for a specific user, or we're actually getting mementos out of users. We need to be able to do transformations, and transformations become very, very easy now as we have this very flexible API that we're working. So let's do the example again. We have our async manager as normal. We have our computation. In this case, we're producing the number 2. Our create basically creates the future of that computation. And then here we can say create. And then we're going to be using the then operation to transform the data. Okay, this is why I was saying when you can return the data, you can transform it. So right here, it works like a map operation in ColdFusion. Okay, so I can grab that data and multiply by 2, then I can grab that data and add 1, and then I can grab that data and just basically say, here's the final result, right? And then at the end, I can basically get my result right here. Okay, so let's try this. Let's see if this works. Okay, so I'm gonna save it and let's see, and boom, it blew up. Okay, and let's say, okay, why did it blow up? Okay, command box. I have full debugging on command box on my machine, so that's why you see so many things. But it says can't cast component print buffer to stream. Oh, okay. I'm trying to actually print something to the screen, but since it's a then operation, it's trying to map it, right? It's trying to actually take the result of that and send it back to pipeline. So in this case, I was like, oh, I don't need a result, so maybe let's just run it, right? So we basically run it, and you can see that now it runs, and the future result is now 5. So this is very, very important, is when you're not actually returning the data or manipulating the data, just use then run. Okay? So in this case, I manipulated the data, and then at the end, basically, I got my result of 5. So if you need to multiply this by 20, right, then you can do the same thing, and now I get a 41. Okay? So now all these computations can happen in an asynchronous manner. So imagine I can get the salary to compute somebody's salary, then I could go compute their tax bracket, and then I could compute their tax return, all in 3 different computations, asynchronous for you on whatever IO bound or CPU bound computation that you want. And then whenever you want to present them, then you present them. Cool thing is that, let's say you're in ColdBox land, you can actually go execute this in a service call. And then in your view, once the view renders, you just do your get. So by the end of the day, when you get now into the view, you basically can now actually get your result and wait a little bit less than just getting the result of the get operation. Okay, so now your views can accept futures, and then your future is going to be whatever you decide inside of those views. Okay, right. So those are data transformations, something that we can do very, very easily right here, the data transformations. All right, most of the time, we are naughty developers, and we create many mistakes. So how do we deal with mistakes? Which is going to happen no matter how good we are, we make mistakes. So you can see here, we still have our asynchronous manager. We still have our computation, our creation of that computation. And now we can say here, I want to create the computation. I want to transform the data by multiplying it by 2. Okay. You can see here, then I'm going to add 1, and then I'm going to run to get the final result. And then here I'm going to do a get operation. So if I do this, you'll see that it works very fast, and I get my result of 5. But let's be a naughty developer and actually do a divide by 0. And it blows up. Okay. And it blows up with an ASCII. Let's go take a look. Division by 0 is not possible. Okay. And this actually happened on my get operation. So if I actually comment my get operation out, okay, right here, and I actually do this, you'll see that there is no exception. It swallowed it. Okay. Okay. So it's swallowed because that exception happened, okay, in this computation in the background. Okay. So what do I do? Right. So this is the issue, especially dealing with CF thread or the vanilla run async in ColdFusion, is that how do you deal with these exceptions? They're being swallowed, right? So, and we don't want to be swallowing any exceptions, okay? They're not very nice. So we can attach our exception handler right here, and we're going to get the exception, okay? And then we can deal with that exception. So now if we actually remember our tracks that we created at the beginning, we're moving from the data track into the exception track, okay? And now into the exception track, this is the important thing in completable futures, is that we can actually pass to other functions in the error track, or actually be smart, recover from the exception and send them back to the data track. So that's what we're going to do. We're going to be able to actually go back into the data track. So we say, you know what? I can deal with this exception. They made a mistake. They divided by 0. But whatever, I'm going to still return and take them to step 1, which is return 1. So once I do that, I'm going to go and put my get back, and I'm going to put my return 1. And now you'll see that I do get my exception visible because I actually printed it right here. Okay. So I can actually log it and address it. Okay. Log it as a good developer. And then I can recover if I want to recover. Okay. And then in this case, I recovered and my final result was 2. So that is great. So let's look at this and play around with it. So let's say we don't return anything. So let's say we messed up and we forgot to return something or recover from the exception track. So if we actually do that, it's going to blow up. Okay, and it's going to do a double log because it's going to log this exception, and then it's going to do another exception right here because there is nothing to return. Okay, so very important to know the differences between them and know how to actually recover from an exception. Right? Now, apart from recovering from an exception, there is a catch-all handler. So this handler can actually trap any exception that happens before the pipeline. Okay, so now we can also have another one which is called handle. Okay, which does, of course, doesn't exist in ColdFusion. Okay, so in this case, I can handle any type of result at this point in time in the pipeline. Okay. So I can say I want to handle, and here's the data, and here's a possible exception. So now it's my job as a developer to say, hey, at this point in time, do we have a null object on the exception, or something really nasty happened before? And if something nasty happened, then I can say, okay, something blew up and return 0. Or if there is no exception at this point in time, okay, I can say, okay, I want to return the data plus 1. So if I do this, then it actually goes to, you'll see that the final result now is 1. Okay. So in this case, we reverted back, we went back, and we returned a 0, and then the 0 basically now gave us a 1. So they have the two approaches here. The on-exception, which basically is introducing exception handlers at that specific point in time in the pipeline. Okay, so the pipeline is important to always remember the pipeline. Okay, so we can be creating different exception handlers at different points in time in that pipeline. Okay, and then we can also be creating different handlers that can actually monitor both sides of the track. So this is extremely interesting that, of course, we have no idea how to do this in ColdFusion because it doesn't exist. But I actually have a monitor or a hook on both data channels at that specific point in time. So it's basically like doing this. And I have my monitor right here. So I'm monitoring the pipeline at this point in time on both channels. And I can say, okay, is there an exception or there is a result? And then I can continue and decide what to do at that point in time. Very, very, very useful, especially with dealing with things that you have no UI for. Okay? And what gets even better is that I can attach both. So now I can attach both. Okay? So now basically I've handled the exceptions that happen at this point in time. I return one. When I get back to my handle, I basically know that I do not have an exception. So I just plus it, and then I plus it again. So very, very important. The API is very expressive, and you can create these pipelines. And remember, these pipelines can be saved and stored. You don't have to be actually creating them right here. You can actually create them beforehand and actually store them in a singleton object and then attach these pipelines to these running futures. Okay. All right. So we still have enough time. Let's continue a little bit more. So let's deal a little bit with timeouts. Okay, because this is something that's going to happen no matter what. There are always rogue operations that are going to happen. Okay, so there are always rogue operations or long-running tasks that we're not supposed to be running. How do you deal with them? How do you monitor them? How do you do exceptions with them? Okay, so let's start looking at long-running tasks. We have an async manager. Again, we have a new future. Okay, we want a new future. In this case, we didn't pass anything to the new future. You can see that there's a run method. Okay, so a little bit more expressive API for you because this allows you to create blank futures. Okay, and then I say run. Okay, what am I going to run in this future? Well, I'm going to do a while loop forever, and I'm going to go to infinity and beyond. And it's going to be sleeping for 500 milliseconds, and then one day it will return a -1, but that will never happen. So if I actually execute this right here and I try to get this value of this operation, we'll see what happens. So I'm going to close my watcher because if not, my watcher will probably die. So what I'm going to do here is I'm going to use my handy shortcut and just run this task by itself. So I'm going to run this task, and you can see on the right that it's going to spawn the task, and it's going to go to infinity and beyond, and it will go to infinity and beyond, because I will never get, okay, to this point, okay, where it's finished, okay. So at this point, it's blocking right here. It's blocked, okay. It blocked right there, and I basically have a task that I've created, and I've lost a thread, okay. I can go to Fusion Reactor. I can go and see it and try to kill it there, but the reality is that it's dead. I'm dead. So I have to cancel it, right, and basically close it down, okay. So what do we do? All right, many things. I can say timeout or timeout. So I can say run this operation or timeout in 5 seconds, and then give me the operation. Let's see what happens now. So I'm going to save it, and I'm going to run it again. So I'm going to go and actually run this as another build process right here in my terminal. It's going to go to infinity and beyond, okay? But then at 5 seconds, okay, boom, it dies. Okay, you can actually see the task died. Okay, it completely died, but it died with an exception. Okay, and the exception is a timeout exception. So basically, you are now putting a fail-safe on this long-running task. And you're saying if this task does not complete in 5 seconds, sorry, or whatever minutes, or whatever you want, then kill it. Okay, and in this case, it died and it's dead, and there you go. All right, so that's not very nice. So let's do a complete on timeout. So this is a little bit nicer and more graceful approach, is that this long-running computation or sequence of computations, remember, or pipeline of computations, I'm going to time them out, but in this case, I wanted to return the value 50. And this can be whatever you want. This can be a service call. This can be a method call, whatever you want. Return it back after 5 seconds, and we're going to be done with it. So I'm going to go and run this now. Go execute it in a new process. Okay, so it's going to start it up to infinity and beyond. It's going to go into process, and then at 5 seconds, it finished, and there we go. Now we have finished with 50. Okay, and it died. Okay. So very, very interesting right now. Okay. We have been able to do this. Okay. Do that specific timeout in two approaches: an or timeout, which will do a cancel exception, or a complete on timeout, which will actually complete and move the future from that pending state into the complete state with that value completed. Okay, this is the reject state. Okay, right. Those are timeouts. Very, very nice timeouts. Let's get a little bit more complex and say, okay, I want to monitor these tasks now a little bit. So I'm going to monitor these tasks now. So let's get what I'm going to be doing. First of all, I'm going to be a good developer. I'm going to create a thread pool, because long-running tasks, I don't want the CFML engine to deal with it. Okay, if you're using run async or you're using CF thread and that thread lives forever, it won't time out. Okay, it's going to live forever in the JVM. So I want control. So in this case, I'm going to create my own little thread pool called my threads. Okay, so it's going to be a vanilla fixed thread pool. I'm going to talk to my async manager. I'm going to say I want a new future. I'm going to do the same thing infinity and beyond, but I'm going to attach it to that thread pool. I'm going to complete it on a timeout. Okay, give me the value of 0 every after 5 seconds. I'm going to take a little siesta right here for about 2 seconds to let this run. And then at the end, I can actually shut it down. And of course, I can say, okay, what was the result of that long-running task, since I have a graceful complete on timeout. So in this case, I can run it now. Okay, and it'll run. And it'll kill after 2 seconds. It's just the time. You see, took it, still continuing, finished, and it's done. I don't get any more infinity and beyonds, and it's finished because I killed the thread pool. Okay? If I didn't kill the thread pool, then if I didn't have something like this, then this will continue because I have no way to interrupt that thread. Okay? So very, very interesting. You can have that. Even if I remove that complete on timeout, right, it will continue. Obviously, this will throw an exception, but it would still kill it. Right. So let's add a little bit more monitoring here. So let's uncomment this. So once we take a little siesta, I want to talk to the future object that we have right here, and I'm going to check, hey, are you done? Or have there been an exception? Or have you been canceled? Okay, so I have these monitoring methods right now available to me, okay, which I don't have on the traditional approaches. Now, this completed exceptionally. Don't let me get started with these Java developers. I don't know what they were saying or thinking when they created something like completed exceptionally. Like maybe they thought they were going to get a prize if they completed with exceptional. But it's just extremely weird. I don't know what they were smoking or something when they did that JDK, but it's fun once you start getting into it. But let's monitor a little bit, okay? And then we're going to finish it at the end. So let me start it off again. Oops, I created a new one. Close it down here. And run my task. So I'm going to run my task again. Okay, so it's going to produce that thread pool, produce that infinity and beyond. It already took my first done. You can see done false, exception false, cancel false. Okay, and I can continue and I monitor it. All right, so let's take another second right here. Okay. And what I'm going to do is I'm going to cancel my future. So here's where things start getting interesting. Okay, I'm going to cancel my future. Okay, and let's see what happens. Right, so I'm going to cancel my future. And after canceling the future, I'm going to monitor the results from that future. And then I'm going to try to do a get operation at the end as well. So let's see what happens. Okay, it goes again, and boom, exception. All right, and the exception is that I actually did a cancellation exception. I actually said, hey, I need you to go interrupt that future, okay? Go kill it, okay? Even if it's running. I can actually be ungraceful and just say like that, and it'll wait for it to die. But I can say, okay, go kill it now, okay? And it killed it, but since I tried to retrieve something, it actually didn't give me that because it was canceled, right? So let me just comment this out so you can see what happened, okay? And run it again. So now it's going to run again. It's going to report back, and then it's going to die because I killed the thread. And then it says here that it was done, true. So it actually moved from resolved to a resolved state, but it resolved exceptionally. It completed exceptionally and canceled. Okay, so it was canceled. Okay, so there are two tracks here to notice that there are ways to track if that task, actually, if there was an exception, okay, when I was executing it, or if it was canceled. Okay, so you have all these capabilities now, okay, to be able to work with tasks that you didn't have before in an asynchronous fashion. Okay, obviously, if there is something like this and I still want my result, then I can be a little bit smarter and I can say, hey, if the future is canceled, right, then presented, right? Obviously, sorry, the inverse. If it has not been canceled, right, then presented, right? And then basically only if it actually finished, right? And if it finished, you can say and if the future is done. If it's done, then, and it's not canceled, then presented. So you have this expressive API now to work with long-running tasks, monitor them, report from them that you obviously did not have before, with the ability to shut down everything and kill everything and do cleanups, which is very, very important. Right. So that is status checks. All right. I think I might have some time for maybe a few more because I'm reaching the marker here. But let's go to combination. Right. So this will be a little bit fun just to do combinations, and then I'll do a final parallel programming for you. But in this case, you can combine two asynchronous operations into one asynchronous computation. So basically, this is like a reduce on steroids. Okay, so you can see here that I have a future called create, which I basically is just a computation that returns a number. So I can say create that specific number. Then I want you to combine that computation with another computation into a third computation. Okay, hopefully your brains are starting to melt at this point, and give me the result. So this is how powerful you can get with these computations, where you can actually go execute them all in asynchronous fashions, and then in another thread, join them and get the result out of them. And in this case, we get a beautiful 5. Okay? Very, very powerful. So this is like a reduce on steroids. Okay. All right. Well, let's do a fancy one before we end, and we'll take a few questions. So we're going to be respectful of people's time. There are more examples here, but I want to show you a little bit of examples of working in a parallel fashion. So when we're starting to work with multiple futures or multiple computations, we start getting into the realm of parallel programming. Okay? And there are many constructs to work with parallel programming. We've done futures that can actually race. Okay, so we can actually use a method called any of, and we can actually use an all, which basically allows you to execute multiple operations at the same time, and an all apply, which actually allows you to do like a map operation on multiple objects at the same time. So let's look at all right now. Okay, this little example here. And what I've done here is I have my run method, and I've created an array of feeds. So I'm going to go out to Ray Camden's blog, to the ColdFusion's blog, to this Modern AI podcast, all these feeds. Okay, as you can see, all I do is say, give me the feed data. And the feed data is right here. It's a function that basically receives the feed, okay, where it is. And I say, okay, I'm going to be retrieving this feed. I run it, and then I return the title and the items. And then through the async manager and say, hey, I want you to parallelize this array. Okay, so I want you to go execute this array, all of them in parallel. And once they're done, I want you to retrieve the results of them. And then I want to go through each of the results that it gives me and print the feed. Okay, so if I actually go execute this, it's going to actually parallelize the execution of all these retrievals, process them for me. And you can see that it starts working. And it presents right here everything, the feed reader right here very nicely. So it went through it. It actually got all the feeds. You can see all the different workers now, getting all the different feeds, okay, processing all the different feeds, and then joining all the different feeds that I want to give me a consolidated result that I then can present. Okay, all with this very small approach to parallel programming. Okay. And there's many permutations that you can use and pass into all. You can use arrays, you can use collections, you can use queries, you can use Java collections, many, many, many things. It'll do all the translations for you in ColdFusion. Then you can actually join all the operations and return a consolidated result. And then I can go through each of the results and print them very, very nicely. All right, let's do the final one, which is a very useful one that we use, especially for APIs. So what I'm going to be doing here is I am going to build objects. I'm going to create mock objects right now for you. So we have an async manager, and we have mock data CFC, which is part of TestBox. And we have a function called getObject, which I'm going to build a fancy mock object with one method called getMemento, which actually is going to give me back a struct of name, age, and ID. Okay, so that's what it's going to build. It's going to build a whole mock of objects with one method called getMemento. Okay, so I'm simulating, let's say, an ORM right here. And I'm going to say to the async manager, hey, I want you to do an all apply. Okay, what do we want to all apply? Well, I want an array of 1 to 200. So the async manager has some utilities to it. And I say, hey, go produce an array of 1 to 200, and then create the objects, because I am applying this function to every item into the array, like a map operation. And then I'm going to be basically getting an array of 200 objects with methods called getMemento. Then I can even pass those objects array and apply them once again to actually construct the mementos out of them. And then for each of those mementos, I'm going to actually be showing you the memento. So if I actually run this, it's actually going to be producing 200 objects in an asynchronous fashion. It's going to then process those 200 asynchronous objects into my results, as you can see here in mock data. So it is extremely powerful. Of all the things that you can do in parallel programming now in ColdFusion that you can take advantage of. So right now, I basically mocked an entire database with object relationships, and I can actually marshal them into JSON if I need to. Right? So if I actually wanted to present that into JSON, then I would present them right here into JSON, or filter them out as I see fit. Okay? I can do a custom executor, all that good stuff. Okay? So all apply. It's basically a parallel approach to going through every item in an array, struct or query, okay, and mapping them, each of them, into a specific function, all in an asynchronous fashion. Okay. All right, lots of things to see, but unfortunately we don't have time. I just want to get into questions, and anything that you guys have questions about, we can do. Unfortunately, there's always, when I do this presentation, I don't have time to show you scheduled tasks, but we have a tremendous amount of things to do with scheduled tasks. I'm writing all the documentation for them right now, but I think I might do just a session on scheduled tasks, because there's so much to do and see with scheduled tasks. So I'll open to some questions right now. By the way, I added a very simple scheduled task on the samples right here, so you'll get it on the actual repository. Okay. Good question, Charlie. So the reality is that slip in code happens more than you think. And I'm sure you've seen this in your consultings, where you actually go to Fusion Reactor and you see all those threads, and you see, they have 100 threads that are stuck, right? So I think that it's Fusion Reactor, as you know, both of us work with Fusion Reactor, love Fusion Reactor. And for me, that's the #1 tool to look at all these things that are happening inside of ColdFusion. Now, we also launched a CB Debugger project, which is very specific to ColdBox, which is a very lightweight APM as well. And we do have support for this as well. So you can actually see all the different threads that are running, all the different tasks that are running as well. And then you can also interact with them. It does, Charlie, because they're just traditional Java threads. So they should be showing you those just normal XNIO Java threads. But I can double check on that. Let's see here, Danielle. Where does a future live if not in the GM when you add them to a custom pool? All right, so the thread pool lives in the JDK. Okay, it's basically a worker. Okay, it's the person in charge of executing your tasks. So when you actually create a future, right, that is basically a representation of your future computation. Doesn't mean that it has your computation in it. The computation is already scheduled into that executor, and at one point in time, your future will be created with the actual results. The actual repository is right here. I'll put it here, and I'll put it in the chat as well. Charlie, I have to verify all the stuff in Fusion Reactor, but I can tell you in our CB debugger, we actually do monitor that. Okay, especially right now we're doing one-off tasks and futures and stuff like that, which are not scheduled tasks. When we start dealing with scheduled tasks, we have a whole life cycle. I can give you a sneak peek of how it looks. So here's in ColdBox, when we have our schedulers, we have the concept of a scheduler. And here's our test scheduler. We have actually all these lifecycle hooks. So you can actually do what happens when you shut down the scheduler and you start up the scheduler on any task error or any task success, before any task, after any task. And then you have a lot of metrics on these schedulers. So every scheduler object actually has a get metrics. See here? Nope, that's not it. Async tasks scheduler. Every scheduler has metrics, and those metrics are available to you right here. So it can actually give you the name of the registered task, its actual future risk presentation, when it was registered, when it was scheduled, if it's disabled or not, if there was an exception, the error message, the stack trace, and which server it was on. And our CB debugger will actually show you all that. Yeah, for CFML, I have no idea. I do not use them, so I would not know how to monitor them. But we are basically building a lot of tools to help you and assist you with the CB debugger project. And hopefully everything will also translate into Fusion Reactor as well. When you don't add a future to a thread pool, why doesn't onComplete timeout kill the future? Okay, it doesn't, because it's not supposed to. It's basically just saying complete the future with a specific result. It doesn't mean kill the computation. So that's tricky, but that exists. You can look at the Java API, and basically it says that it will basically give you a result at a specific time and point in time, but it won't cancel the actual execution. So it gets a little iffy, but. You mentioned how simple executors mimic a FIFO queue. I'm architecting something that was going to use an AWS SQS, but I'd rather use CF if possible. Any red flags for running a queue this way? Okay. So not really any red flags, Doug. So if you actually create an executor, okay, which is basically a FIFO executor, the executor object, as you see here, is fully documented for you. Basically, you have a nice little function called submit, okay? And all you do is submit tasks to it. Okay, so you submit tasks to that executor, and they're going to be work on at any point in time. Okay, you can also get a scheduled executor that works as a FIFO as well with one thread. And then the cool thing about the scheduled executor is that you can schedule tasks with specific delays. Okay, so you can say execute this task after 5-second delays, X delays, or you can create periods, right? And you can say I want to execute a task every 5 seconds, and it has tons of methods, as you can see here. We can create the scheduled task here with different operations, right? You can do every, let me go to the every methods right here. You can do every minute, every hour at, every day at, every week, every month, every year, weekends, weekdays, first day of the month, first business day of the month. So you have all these capabilities built in for queues. So in reality, we are working on a queue port as well. So apart from scheduling just tasks, the scheduled tasks, we are going to be working on an actual event queue approach as well, because we have all the tools at our disposal at this point. Now remember, all of them are fully documented. Everything's on the API docs as well as the documentation. So, and if there's anything that we don't have, then please let us know.
All right. Well, it looks like that may be it for the questions. Any last opportunity? Anybody? And if you're typing, we can't see it. So you might want to send a little chat that says, wait. There you go. You see that? I just popped it up on the screen.
As far as the ColdBox applications that use Futures, well, ContentBox right now is. Actually, the ColdBox framework itself is using Futures and scheduled tasks. So they're all there. And the test harness inside of ColdBox is where we're doing that. The API docs, I'll give you the link right here. Let me go here, API docs. I'll send it to you. Give me 1 second. Box. Let's look at version 6.4 right here. So these are the API docs. All the scheduled tasks and all the scheduling will be available in 6.4, which I'm working on and should be released either by the end of this week or so, basically tomorrow or next week. Basically, this is the scheduler that I was talking about, which allows you to register a task by name, what is the specific task that you want to execute, the frequencies, and also life cycles that you can attach to every task. Okay. You can even say on one server. And if you have a cluster of servers, it will actually just run on one server instead of all servers. Yeah, the API docs link is right there, Danielle. So you can click on it and you will see all the async packages and the tasks packages as well. Ortus Books, I am working right now on all the documentation because the majority of the scheduled task features are on 6.4. The rest of the stuff is already on the Git book. Let me send you the Ortus Books, and the actual link is right here for asynchronous programming, sorry, right there. So all the completable future stuff and the executors are completely documented, as well as the parallel computations. The scheduled tasks are the ones that are basically, they were there before, but now we've taken them to the next level with our schedulers and our task schedulers. Our task schedulers.
Hey, Luis, I know you've been saying you've been putting in links and stuff, but and I see Dwight saying the same thing. I wasn't seeing it. I wasn't seeing it in here, and I wasn't seeing it in the YouTube.
You know what? Because I was putting them in YouTube, but I think you have to approve them.
Oh, because you're not a. Yeah, it's like on the podcast when people do that.
Yes, well, exactly. I'm a non-trusted individual.
Yeah, that's curious that they do that. Now, have you? I'm not seeing anything obvious like saying here are messages that aren't being shared. So you guys have done this on the podcast. How do you find the ones that are not getting through?
You know what? Let me send them to you in the private chat.
Yeah, for sure. And
that
I'll
way
pass
it'll be easier. But we might have to ask Gavin because
right. He'll know how. Yeah, for those who don't know, with YouTube Live, they don't let people pass through messages with URLs. They just block them.
Mm-hmm.
And you don't know that it's happening. You're not told, and I can't find where I, as the host, am told, which is really frustrating. So did you? Oh, you put them in the private chat. Okay, just a second. All right, so here comes the Ortus Books. And then I got to switch back and forth between the public chat and the private, and not forget to just post it right back to the private. All right, so there's the first one. Here's the API docs. Yeah, as soon as you said there's the API docs, I was like, I didn't see that. Where was that? Oh, I did it again. So easy to put it in place.
I forgot about that feature of the YouTube blocks.
Yeah. And then this. Yeah, which I had shared this one a couple times already, but do it again. Okay, so everybody should see those three now.
Cool.
So any last comments from anybody else? So Daniel, you asked, will the YouTube description be updated with links? I don't typically do that because it'd just be too complicated, but now they're there. So let me say one thing, though, that is another frustration about YouTube, which is that as soon as we're done, this recording will be available in YouTube. Anybody that goes to that same URL that you guys are at, they'll be able to start playing it over again. But curiously, the chat, and Luis, you should understand this too, in case you come looking for it, the chat doesn't show up for like hours, which doesn't make any sense, but it's a YouTube thing. I have no control over it. I don't think I've noticed that with the podcast. And by the way, let's say for those here who may not know that Ortis Solutions runs the Modernize or Die podcast, hosted mostly by Gavin Picken, sometimes with Brad Wood, sometimes with others. So I'm focused on thinking about, so the URL, what would be the easiest way for people to find that? Of course, they could Google it, but isn't there a site?
Modernize.io, modernize.io.
Modernize.io. And it's every Tuesday.
Yeah.
Yep, and it's every Tuesday at noon Central. And then it too is done as a YouTube live stream. There you go.
Yeah, I'm right here. All the Modernize or Die. You see all the podcast links from here. Yeah, but we're very excited about this new release in ColdBox to bring all this scheduling capabilities into ColdFusion developers' hands. I think that it has been a game changer for us to be able to do all these asynchronous and parallel computations. It brings us up to par with any language at this point. We've always had them. It's just now exposed through these APIs.
And indeed, thanks for all you guys do for modernizing CFML. In fact, why don't we take a chance also to throw up there the link to your Modernizing ColdFusion book. Oh, you have one page in there on the futures feature that CF added, so it's not much on the topic.
You can go to Learn and Books, and you have the 102 tips, and you have the Learn Modern ColdFusion 100 minutes. You can read them there.
Yeah, lots of other things in Modernizing CF in the other book. Dwight says, I hope you do this stream at this time slot again, Easy Australian East Coast. Exactly. So we offer them at noon Eastern to benefit the people in Europe. We offer them at 6 p.m. Eastern to reach people in Asia Pacific. And unfortunately, it's the speakers that decide. I don't have any influence other than pointing that out and letting them decide. So Dwight, unfortunately, they seem to pick the noon slot more often, and that does mean, unfortunately, that you guys in Asia Pacific would be asleep, but at least you can watch the recording, and thank you, Luis, for
this time slot was fantastic. Yeah, this time slot was perfect for me.
So, yeah, it's good for you. And so everybody else, I'll just repeat that if you want to present, I'd love to have more presenters, and especially people that would like to do that 6 o'clock slot, 6 p.m. Eastern slot. And we're just always looking for more presenters. All right, well, I'll let you get going then with the rest of your day, sir. Thank you very much. And we're planning to have Luis back on, perhaps with Gavin, to talk more in the future about just evangelizing more about Ortis products in general, especially from the perspective of people who are not yet familiar with the products and what Ortis does, the resources that they offer, and also things that you can leverage without necessarily, for instance, using Content Box or ColdBox.
All the boxes.
Yeah, but there's things that you can do where you don't need to be writing a ColdBox app. Like with cbFutures, that's only going to help you if you're using ColdBox, right?
Nope. Nope. So like I said at the
I missed
beginning,
that. I thought about asking that. Okay, go ahead and clarify.
yeah, no. Actually, so if you have command box, you
Right.
have synchronous capabilities already because it's built on Wirebox. So if you're building command box tasks or command box modules, or actually command box scheduled tasks, which are coming, you have them right there. If you have a legacy ColdFusion application, you can just install Wirebox and you get it. If you want caching, you can get CacheBox and you get the asynchronous package. If you want logging, you can get Logbox and then you get the asynchronous package. So the asynchronous package is available to you whether you use ColdBox or not. And that's what we wanted. We wanted this available for any ColdFusion developer.
And I don't know if you'd made that point earlier. It's kind of a bummer if we didn't clarify that, because some people just turn off if they go, well, I'm not writing ColdBox apps, so it doesn't apply to me. But at least if they listen to the end, they'll have gotten this. And if you did say it earlier, good for you. I might have missed it. But this also, if they're not using command box for running their apps, they can add these things via ForgeBox.
Yes, correct. So yeah, and I put it right here also as well in the little agenda and everything that you can use this as separate, right? So you can use this as a standalone project.
Cool. And that's, like I said, that's part of what I would look forward to in another talk, is to bring to people's attention, without focusing on any particular thing in any depth, but to bring to people's attention, here are things that you can leverage in a legacy app. Or here are things you can leverage even if you don't use command box, because there's audiences for all that. And then, of course, there's great stuff if you buy into the entire framework and ecosystem.
Yeah, basically, if you use ColdBox, you get more enhancements, right?
Yeah.
That's the way it works. So you get everything. If you have a non-ColdBox app, so any ColdFusion application, any legacy app, whatever app, it doesn't matter. You get the basic functionality, and then if you are in ColdBox, then you get a lot of extra bells and whistles, basically.
Yeah. Cool. And thanks, Daniel and Dan, for your comments there. All right. Well, very good. So let's go ahead and call it a night then, for those of us for whom it's later. Good morning to you, Dwight, or good afternoon if it's soon.
Exactly.
Your time.
All right, Charlie.
We'll see y'all next time.
Thank you for having me. Appreciate it.
I'll see you soon.
Bye-bye.
Bye, everybody.